Hey, hello everyone. This week in class and lab, we're talking about weathering and erosion. And of course, those processes are extremely vital for our survival because the ultimate end product of the weathering of rocks is soil, and we are extremely dependent on soil for food. It does come into play with our everyday existence. And of course, weathering and erosion does help to create many of the spectacular landscapes and features that we see on Earth's surface, and we are therefore allowing us to enjoy them, perhaps at a national or state or county park. We're going to be doing a few. I'm going to be doing a few demonstrations here to simulate the weathering process. So I have 3 cups of room temperature water, and I'm going to drop something in there, something that you're already used in the Volcanoes lab, and that's an Alka Seltzer. And the Alka Seltzer tablets will serve as an analog to rocks or sediment that exist in nature. And we are interested right now for these 3, and the reason I'm doing it 3 times is because I'm using an Alka Seltzer, a whole Alka Seltzer. I have another one cut into quarters or 4 pieces, and then another one that is in powdered form. And we're kind of interested in seeing if that has any effect on the rate of weathering and how quickly they will dissolve once they're put in the water. We know that surface area of a rock and how much is exposed to the atmosphere, which of course is the big agent of doing a lot of the weathering or most of the weathering on Earth's surface. How much is exposed? It almost seems contradictory or misconception that when we cut it into quarters, we end up with less surface area, but we're actually exposing more sides to the tablet, and therefore that increases the surface area. And of course, when we have it in powdered form, even though those pieces are very, very small, they have a lot of surface area, so it actually increases as the pieces of the sediment or our Alka Seltzer gets to be in powdered form. Let's do this. And as I drop the first one in, I'm going to put the timer on. I'm going to try and get them all in within a few seconds, just to see how they react and how long it takes to react. So I'm going to drop that whole tablet in there. I have 4 pieces, 1, 2, 3, 4. And then I have my powder. And you can see in powdered form, it reacts much more there's much more effervescence. It bubbles up a lot quicker. And it's pretty much dissolved. And that was after about 20 seconds. The entire tablet is dissolved. If we look at, you can probably see the tablet on the left one here, the whole tablet is still pretty much a whole tablet. And in the middle, which was the quarters, they are just about all dissolved. And there they go. And they're pretty much done. The whole tablet is almost right behind. So we really need to, and that took about a minute. And so we see that just about, even just cutting it in quarters, is about the same time. It slows it down, it quickens it just enough, the weathering process just enough because a few more sides are exposed. But the powdered form, so when those sediments, that rock gets into a number of pieces and more sides are exposed, we really hasten the weathering process. So increase in surface area just accelerates the weathering process. So now we're going to do this same process again. We're going to use quarters or a tablet that's cut into fourths. And we have a few different variables here. So we have our 3 cups. And now what we're going to do is see the effect of changing temperature on these sediments or rocks, which are the Alka Seltzer tablets. So I have a cup of ice water here, and I'm going to pour that into the first cup. So that's nice and cold. I might even, why not, just add an ice cube there, just so you can see that's definitely some ice water. And behind me, I have some water heating up on the hot plate. and I'm going to do something kind of against lab safety here, but I'm going to take this with my hands. It's not too hot. And I'm going to pour it in this middle cup. There we go. That wasn't so bad. And then the third one, I'm going to add some regular room temperature water. And the one thing that's going to separate this is that I'm going to add some acid to it. So we know there's acid naturally. Mother Nature makes her own acid called carbonic acid, which is created in the atmosphere through water and carbon dioxide. And so that's everywhere. We can't really control that. So I'm going to add a few drops of acid. I know some of you went really heavy on the acid. I won't mention any names in the Minerals and Rocks lab. And that's to kind of simulate the idea of acid rain. Rainwater, of course, is naturally acidic, but of course, pollution by humans could decrease the pH or acidity, or increase the acidity, which is what you're doing when you decrease the pH level of the rainwater. So we have some acidic water, some warm water, and some ice water. So let's take those 4 pieces. And let's see what happens in the cold. And let's add some 4 pieces to the warm. Whoa, that went right up. And so we see warm temperature water. And here's the acid. And that's also getting a bit of a haste acceleration. Not as fast as the warm water, but we see the acidity with the quarters definitely is increasing. So it took about, for the regular tap water, it took about a minute, little over a minute, for those 4 pieces to dissolve. And the addition of the acid, and I used the hydrochloric acid, but you could use vinegar, a very common acid, to see that. And I'm looking at keeping an eye on the time. The cold water is just really not doing much of anything. The warm water has been dissolved. It took about 10 seconds, less than that. The acid is almost dissolved. The acidic water is almost dissolved, and there it is. So the acid took just about a minute, little less than a minute, and the cold water is just plugging along, and that's probably going to take another couple minutes or two. So we see that temperature can also impact the rate of weathering. Very warm and moist climates tend to have increased rock weathering rates. Very cold climates tend to slow down, but they take a different, because there's ice involved in cold temperatures, we have kind of a freeze-thaw action. So it's a different kind of weathering process in more polar and Arctic areas. Any kind of acid to rainwater or snow and ice can also accelerate the weathering process. So by decreasing the pH, and of course there's plenty of Mother Nature's acid on the earth and in rainwater. That's carbonic acid. That's the combination of water and carbon dioxide. So we saw that increasing the surface area seems to play an effect, and changing temperatures and acidity also seems to have an effect on the weathering process. And so there'll be a few questions in the lab for you to consider based on these demonstrations. All right, have a good lab.